What I want to talk about today and what I've been doing for over 15 years now is engaging with a new approach to retrieving information about the history of infectious diseases. And this has come out of left field. It's come from an entirely different discipline than the history of medicine. And one of the big questions I want to talk about today is where does history of medicine fit into this new configuration of what is possible now? Okay, so the talk is divided into four parts. I'm going to start with an introduction where I am explaining what paleogenetics or paleogenomics, as it is also called, what that is and why it has been so transformative. Then I will give the example of three different infectious diseases of how ADNA, ancient DNA, has given us new kinds of information. In some cases, really kind of radically transforming what we thought about these diseases. The third part of the talk will move into plague, which has been my own specialty. I'm a medievalist, and so plague is always been a very big issue on the table of historians who work on the Middle Ages. And then finally, I'll wrap up with some conclusions about where we are now and where we might be going. Let me first explain this photograph. This is a photo that I myself took in 2016 at the Museum of London, which houses the physical remains of the individuals, well, a variety of collections, but it houses the remains of the people who were buried in the Black Death Cemetery in London in the late 1340s. And I can explain more later about why I wanted to look at the sample in particular. But I wanted to start with a visceral sense of what the difference is now, this new world that we're living in, because up until very recently, what historians of medicine of the pre-modern period did, so, for this purposes, it's really up to the late 19th century and the onset of bacteriology, and then afterwards virology. What we had to do was just read texts. What is possible now is to read the physical remains of the past. There's another discipline called paleopathology, now part of a larger field of bioarchaeology, which also looks at the physical remains. And they've been around for more than a century. So it's not that the physical remains have never been on the table before in terms of discussion, but there's a radical new way in which all of us are being informed about what's possible. And so anyway, this is this individual, a woman who's probably around 25 years old, who died during the Black Death. And what can we know about her now? Okay, so just to make this very quick, I'm going to cheat and use a popular reference, which is we already know what ADNA is because it has already become part of popular culture with a novel that Michael Crichton published in 1990, and then with Steven Spielberg's movie first released in 1993. This concept of getting the physical remains of the past at a molecular level. And so the conceit of the book and the movie, of course, is that mosquitoes were feeding on the blood of dinosaurs. Mosquito gets caught in amber. The amber gets caught in sap. The sap turns to amber. The amber is retrieved as a hard rock, and then scientists go in and retrieve dino DNA. And in fact, there are ways in which this scenario has already happened. So the ways in which these insects are being found in amber. So what's over on the right is simply a list published in 2021 of the major highlights in the field. So this is Orlando et al., and I refer you to that for all of the details. And I just want to highlight here there is already pathogen research that started well before this, but 2011 was really a transformative turning point because that was the first point we got the first nearly complete genomes of a pathogen from the past, which was Yersinia pestis, the organism that causes plague, and also very relevant to my field, and also coming from the general area of the graveyard in London that I was just talking about. So that's a quick summary of the past. Why has that changed what we do in the history of medicine? So the field of bacteriology developed in fits and starts, as many of us know, over the course of the 17th, 18th century, but radical transformations in the 19th century, which I am summarizing now simply by showing this microscope that was owned by Alexander Yersin, the scientist who discovered Yersinia pestis. This is the kind of machine that's being used now. When I talk about microscopes, in fact, microscopes are almost irrelevant at this point. This machine looks like a cross between a photocopier and a refrigerator. It is actually one of the most sophisticated machines that is being used now for genomic sequencing. Why does that make a difference? When we're looking under a microscope, looking at microorganisms, in this case, bacteria, you're only seeing the species. You're seeing the whole cell. You're seeing various parts of the cell, but everyone is basically going to look like another one. So this is Yersinia pestis. This is actually an electron microscope, which is even more sophisticated than what Yersin was using, but it gives you a sense. You're just looking at the whole thing. When you're doing molecular analysis, you're looking at every molecule. What you're looking at is the ability to study the whole genome. And when you can study the whole genome, you can identify strains, distinctive genetic differences between one sample and another. And what I've given you is over on the left. I know it's illegible, but basically that's the level of sophistication that is now achievable. Okay, so how does that make a difference in terms of what we do as history of medicine? As I said, we historians of medicine were tied to text, to verbal descriptions, to humans describing what they saw, what they felt, what they experienced, how many people they saw dying, the visible symptoms that they could see. Maybe in a urine glass, they could say, okay, this is the character of the urine of this person. But the ability to see microorganisms was never there in the past. And that's the difference that we're seeing now. Those cells of any bacteria would immediately break down. There would be nothing that a microscope could look at. Molecularly, we can reconstruct these histories. So what I want to do first is talk about several examples of how paleogenetics has told us things we didn't already know, and then start laying a foundation for what kinds of questions medical historians need to ask now, the kinds of questions we can ask for the first time. So first example, smallpox, a virus, but it is a DNA virus. The RNA viruses have also been retrieved, a lot harder, smaller, so forth. But smallpox obviously is has a very big place in medical history. In terms of the results, ADNA for smallpox, for variola virus, has been found dating back to the early Middle Ages. Major historical questions that we can pose now is when, where, and how did the common ancestor of this medieval strain that we have found, what's generically called the Viking strain, what was recognized because this is genetic analysis and you can track the evolution of the organism. This Viking organism was clearly not the direct ancestor of modern smallpox as it was documented, as it was studied in the 20th century before it was eradicated. So that divergence happened a long time ago. That divergence may have even happened before the Middle Ages. So a lot of questions. There are clear similarities. There's clear genetic lineages that they share, characteristics in the genomic structure, but they are different. So is that really smallpox? Does it have the same symptoms? All of these questions are now on the table. The other question that needs to be asked is smallpox, as we understood it in the 20th century, was an obligate human pathogen. It was only infecting humans, being passed from human to human to human. And because of its character about its disease interval, the time between infection and resolution of the infection, and also the fact that, as it was understood, it created lifelong immunity, you would have to have huge populations to sustain a disease like that. So, at what point was it able to do that? Okay, as I mentioned, paleopathology, the study of the physical remains of the past, has been around for a long time. Studying the lesions involved in smallpox actually is fairly recent, as we've come to understand what these lesions look like and how they connect to a smallpox infection. What happens with smallpox is that if you are infected as a child and if you survive the infection, it is very likely that certain kinds of infections will have gotten into your bones and deformed them. So these images that I'm showing you now are survivors of smallpox, but showing these very characteristic lesions. This is a study that was just published last year. Osteomyelitis variolosa is the term we give to this infection. These are from Roman Britain, from the third or fourth century when Romans still occupied Britain. So just being able to look at these and make this kind of analysis is what is now possible. This is from this same study from last year, because there were still survivors of smallpox alive in the 20th century. They were able to find these x-rays of smallpox survivors and document these conditions in the bones that were separate. So those were the x-rays. Those are 20th century x-rays on the left. In the middle there is another example from, it's either a medieval or early modern grave site in France that is again showing these kinds of characteristic lesions in the bone. So we know what to look for when we're looking for smallpox. And again, because we can already get back to third or fourth century, we know how deep it is. This is the Viking study that came out in 2020. Already in 2016, there was a study of a Lithuanian mummy that retrieved smallpox. And even then, they said, listen, the strain that's in this 17th century mummy is not the direct predecessor of the strain that's circulating in the 20th century. So that's why they're already inferring we have to probably go back several, at least a century earlier, or certainly in certain kind of genetic time, we need to go back earlier to find the common ancestor. So those are the blue lines there. What we also have here is an indication of where, at what genetic point the Viking smallpox and the modern strains diverge from each other. So it's actually quite a long time ago. It might be getting back to Roman times, might be getting back earlier than that. Again, you can say what's before and what's after, but you can't say exactly when, judging from these phylogenetic trees. But it gives us an indication. Okay, and so before we leave this, just note on the map where these samples come from is they are there's two 7th century samples coming, one from Norway and one from Sweden, and then a 9th or 10th century sample coming from Denmark, and then a sample from far Western Russia that is coming from the 10th century. Okay, this is a study published in 2024 from Spain, looking at Spain. And what they're finding is that's the Spanish one is the red one in the middle there, added to the phylogenetic trees. And they're saying essentially we found the same thing in terms of the phylogenetic structure of how these different strains are related to each other. So we have modern strains, the closest ones related to human smallpox are Tetrapox virus, which has been found in rodents, and camelpox virus, which was found in camels. Then we have our increasingly large clade of Viking smallpox. And right before the Spanish one was published, there was another one from Germany. So 7th, 8th century, and then 9th and 10th century. And then we have our modern smallpox. So one of the things that has been amazing to watch over the course of the last decade or so is with each new genome, we learn something new. We learn something new about the geography of where these diseases are being spreaded. We learn something new about the relationship of different strains to each other. So all of this is good. All of this is wonderful. And we're also still asking this question, when did this medieval strain diverge from what became the modern strain? And we still have these questions of what are the symptoms of this medieval strain. This is a study that just came out last week. And it is an archaeological study looking at these various people in Yakutia, which is southern Siberia, very, very far in eastern Eurasia. And what they find in 18th century samples are 3 instances of smallpox. Now, how does that Yakutia, the Yakutia genomes, the 2 better ones that were found, how does that relate to the Viking ones? Well, those are the Yakutia ones. And as you can see, they don't cluster with the medieval ones. They cluster more closely with the modern strains. But what the addition of these new genomes does is it breaks apart that medieval one. And it tells us something more about how they relate to each other. So originally in 2020, it was thought that the modern ones diverged before any of the Viking strains did. Now we understand it as one of the clades of the Viking diverged later. So we have some general sense. And so just to give a summary, what it seems to be saying in terms of timing and in terms of geography is that the earliest strains we have are in far western Eurasia, and the disease seems to be gradually moving westward. And Yakutia, of course, is also the first samples that we have from eastern Eurasia. So it's looking like perhaps something either is in common in terms of the Russian background of this. Yakutia was taken over by the Russians in the 17th century, which is part of the political context of some of these changes. So we're getting a sense of some elements of the history of this disease. What we don't have is a sense of the when it's becoming human obligate. This is a statement I made in 2018, at the time gathering up the information that was available about infectious diseases in Eurasia. Smallpox has long been suspected as being a factor in the Antonine Plague in Rome in the 2nd century, still not been proven. But there are other indications that late in the Roman Empire, 4th century and the 6th century, seem to be smallpox. And as I've said, we already now have some indication from Cirencester from Britain. These would seem to form a chain with persuasive descriptions in Europe and the Eastern Mediterranean going back to the 6th and 7th century. Narrative accounts of what seems to be smallpox go back to the 7th century or earlier in Indian records and to the 4th or 5th century in Chinese records, suggesting eastward movement of the disease. Will this be panned out when we get more samples of these pre-modern smallpox strains? I don't know. But the point is that we can have some kind of dialogue between the results of ADNA and the historical written documentary record that we have. Keeping in mind that we always have to be interrogating the terms being used, the descriptions being used, and so forth. Um, and if we then compare that to what's happening with mpox, formerly called monkeypox, we have some sense of possibly the involvement of rodents. Okay, leprosy. Results confirmation that the what we now call the old leprosy, M. leprae, which was discovered by Armar Hansen in 1873, that likely has old world origins, so far as we can document those now. And it's certainly been disseminating in human populations since the Bronze Age. Very strong indications of Pacific Rim origin. So exactly the opposite side of Eurasia that we saw for smallpox. We also have confirmation of a new species of leprosy that was discovered in 2008, and already in the early reports, 2009, 2012, it was being suspected because of the pattern that was being found in modern cases of this disease. The question was being raised, is this in fact an America, a disease of the Americas? And we've now gotten confirmation that, in fact, from ADNA, these two studies were just published last year, that we can go back at least 10,000 years for the evidence of M. lepromatosis in the Americas. So the historical questions is, how do we integrate all this new information into our histories of leprosy, of which we actually have many? Because leprosy, as we understand it, is a very visible disease. It's also a disease in which, in many cultures, there are strong social reactions. So we do have this work of integration. And here we have this was the study, a study that came out in 2004, which is documenting for the first time the role of a rodent in the dissemination of leprosy. This is a study of English evidence, and there is um, uh, genetic evidence now to show the presence of leprosy in squirrels. Modern squirrels in the UK had already been discovered as being infected with leprosy. So, in all of this work, in fact, there is a dialogue going back and forth between modern results and the historical results that are being portrayed. Um, this is an example of actually, there was a historian, I'll mention her again later, a historian who was deeply involved in this project. And what she was able to document, a medievalist who was able to document that squirrels are actually kept as pets in the Middle Ages. Squirrels are also very regularly used for a highly prized kind of fur lining for cloaks. The pattern that's being showed there is completely typical. It's basically you take um, a light colored coat from a squirrel, a dark colored coat from the squirrel. Sometimes it's just the belly and the back of the squirrel, and you create this alternating pattern of triangles. The pattern is called ver, all over the place in medieval art, which is one of the ways in which it is we can now document how very common this use of squirrel fur was. This is a disease being passed between animals and humans. This is the study, one of the studies of M. lepromatosis, again, just came out last year, and just putting together this really amazingly complex history out of a disease we only discovered in 2008. What they found is there are significantly high mutations, thousands of mutations, which is very distinctive of this disease, suggesting that it may have, the more common modern one may have diverged more than 9,000 years ago. So that's the present day clade. There's also indication that leprosy increased in its spread after European colonization. So we can't show it here now, but the old world leprosy was in fact brought to the Americas. We can find them, find those strains all over the Americas, but that's coming on top of this leprosy that was already present in the Americas for about 10,000 years. Historical questions we need to ask are, how did people react to this disease? You know, what kinds of social interventions. How did they understand it? There is this strain that probably diverged about 10,000 years before the present that still survives, in fact, here in the United States. Okay, tuberculosis results. MTBC, the Mycobacterium tuberculosis complex, seems to have originated in East Africa as a human obligated disease that we then pass to other animal species, and sometimes they have passed it back to us again. So this is very distinctive. Another thing that's distinctive about the case of tuberculosis is that most of the genetic analysis, most of the evolutionary analysis, has come from modern samples. There are millions of people in the world infected with tuberculosis still. And in order to control the disease clinically, decisions have been made to essentially do genomic testing of when a new diagnosis is made because of concerns about reactions to the modern medicines that are being used, antibiotic resistance. So there's a huge amount, tens of thousands of genomic samples to study here. Major historical questions: how do we identify what those anthropogenic activities were? Those instances where we're giving a disease to animals, which sometimes they give back. And I'm just going to go through this very clearly because it's to really understand it, you have to be able to read the fine print, and we don't have time right now. But this is the global phylogeny of tuberculosis as of 2025. So these are all the major strains that we know about. And what we can see here by taking just a close-up of that previous tree, this is just the bottom half of it, is we can start to see where those divergence points are. And when we line them up and look at the geography of where in this case, these are all modern samples, what they're showing to us is that this is a disease that originated in East Africa and has been spreading from there. And also we can see the ways in which the strains that are found in animals are also part of this dissemination within Africa. This is the most recently, I'm sorry, this is not the most recently, but it also shows that in terms of the global dissemination for the disease moving into Europe, India, East Asia, Philippines, and the Indian Rim, that the earliest, the most basal strain we can identify right now is found in Ethiopia. And here I just want you to notice M. pinnipedi, Mycobacterium pinnipedi, it's the disease found in seals. So another historical question that's been on the table, again, for many decades because the paleopathologists were already involved, is the recognition that there is skeletal evidence for what seems to be tuberculosis in the Americas in the pre-contact eras. So long before we have any evidence of Europeans coming, there seems to be tuberculosis in the Americas. So that's been a question on the table for a long time. 2014 is when this amazing study was published, documenting going and looking for aDNA in samples from South America, in this case from Peru, and finding that the strain that is found in pre-contact Americas is most closely related to the strains that are now found in seals. What I did as a historian was say, wow, how in the world can we explain how the peoples of the Americas are infected with a disease that is actually I forgot to say, the aDNA that was found of tuberculosis suggested that tuberculosis as a disease was only about 8,000 years old. So if tuberculosis is found in the Americas before European contact, then we have an inherent historical puzzle, is how did it get there? And this study essentially answered that question, but opened up a gazillion new ones, is, wow, what is going on that seals are able to, if it is in fact the seals that are doing this, that seals are able to convey this disease from Africa to South America and infect humans. So what I did, and nobody has picked up on this, nobody's even cited it so far as I can tell. But what I did was just say, well, if humans are involved in South America, humans are probably also involved in Africa. And what I found that, yes, in fact, there is seal farming, if you will, going on in both places. That humans are basically when the seals come up on shore to rest and to breed, they are just there for the picking in terms of human hunting. Okay, so let's pause and say, where is history in all of this new work? In 2014, I wrote this essay, which I published in the magazine, not the journal, but the just kind of the monthly magazine of the American Historical Association, with the intent that I wanted to say to as many historians as I possibly could, hey, there's this new field that is happening. There's all kinds of amazing things that are going on, and this is history. They are recreating change over time in relationship to these diseases, and I think we should accept it as a new player. How do we engage with this? What I have found is, in terms of my engagement, obviously has continued, but in terms of the geneticists, in terms of the archaeologists who are doing this work, they have essentially treated history as irrelevant, history as it has traditionally been practiced. So, for example, the smallpox in Yakutia, for example, was found in the course of just other archaeological work. They weren't looking for smallpox. They weren't trying to create a narrative of smallpox. They just happened to find it in the bodies that they were looking at. With leprosy, the study I just mentioned on the squirrels in the United Kingdom, the major works on European leprosy aren't even cited in the work. The study on tuberculosis has 184 references. None of them are historical, except for citing the World Health Organization's own histories of their eradication program. This is a study that just came out a couple of weeks ago, surveying all these different kinds of ways in which ADNA has been studying pathogens and looking for them. And it has 165 citations, 0 historical studies. So history of medicine has been left entirely on the sidelines. That has not happened with plague, but we can also see a lot of ways in which this field in particular, some really big messes have been created about trying to get the genetic evidence and traditional historical evidence to work together, to talk together, and so forth. This conference that was just held in Bordeaux in October actually brought together historians of plague, mostly working on the medieval and early modern period. Was there good dialogue? We can talk about that later. But basically, biology and history need to be talking together. And are we doing it? So here's confirmation of the role of Yersinia pestis. So there's no question. Again, we've got the material evidence now to be able to talk with confidence, with complete confidence, that Yersinia pestis is involved in the historical pandemics that we already had in our narratives. We're also able to talk about the global evolutionary history of plague. The major historical questions I've divided into Justinianic plague era and the Black Death. So the first plague pandemic and the second. So here's our global history. I'll just zip through it. Basically, when you get all the genomes together, you really need 3 or more. When you have thousands, you can do amazing things. This is a study that was published in 2020. It's already ancient history in terms of the numbers of genomic sequences that we have for Yersinia pestis, both modern and historical. But it's because it gives just a nice, simple outline with color coding, it's very clear. So there at the top, at the blue, is the third plague pandemic. This is a plague pandemic that is essentially kind of declared a pandemic late in the 19th century. Plague is essentially migrated down into uh, cities, getting into port cities, and then jumping on steamboats that are coming out of Asian harbors. And via these steamboats, plague is disseminated around the world. So, one of the things I always say in my talks is I live in Arizona. We have plague in Arizona. It's because of this dissemination in the late 19th century. It is also the period in which we get plague erupting under the nose of modern science. So, virtually all the science that we have about plague is dating from the late 19th century and on. And the amount of science we have actually is quite huge. Here we have the Black Death, so in the middle of this evolutionary tree. And the areas of this tree that are shaded in the background, those are samples that come from ADNA. So already 6 years ago, this is how much was available in terms of ADNA. There's much more available now. Justinianic plague at the first plague pandemic in the early Middle Ages, and a complete discovery of this new era of ADNA is the late Neolithic Bronze Age lineage. Nobody had a clue that it existed before. So basically, we can talk about plagues history, again, on a global level, going back at least 6 to 7,000 years. The latest estimate is actually, it's not cleared peer review yet, but is estimating maybe even 10,000 years of this. So amazing information we have. How do we connect this with our understanding of the narratives we've already created that we've had essentially for decades, centuries even, of these pandemics? So with the Justinianic plague, we have been finding plague where we expected it to be, so around the Mediterranean, for example. We've also found it where we didn't expect it to be, like in Bavaria, where we had no documentary record that it was there. That's one of the ways in which we're just constantly having to wrestle with this of finding things where we never expected it to be because of the limitations of human documentation. Questions we have is essentially, again, we have this global understanding. What was not shown in the phylogenetic tree I just showed you is the geography of where those samples are coming from. But basically, the geography, once you add in the geography as well as the evolutionary development, you can actually start to say where things are coming from, just as we already talked about with tuberculosis, smallpox, etc. Justinian plague historiography is, I would say, as an outsider, it's not my special field, is a mess right now, in part because of ways in which the historians, some of the historians who were coming into the field really didn't understand what genetics, paleogenetics could do, some of the basics of archaeology, and so forth. So, but basically, this is where we are now. This is a study published in 2019. There's another study. Maybe it's coming out this year. I've already heard previews of it now, which will be complicating the narrative that comes out of this evolutionary, this phylogenetic understanding. But basically, we have samples now from several different places in Europe, including Britain, and also the most recently from Jordan. And some estimates are being done. Again, we can talk about the issues involved in these datings, but the starting point from this is the documentary evidence for a major pandemic that started in 541. But that evidence is coming from the Mediterranean. If this is an Asian origin, how do we connect that Mediterranean narrative with the Asian narrative? And we're still figuring that out. So this is just some, again, the ways in which we use modern genomes to make inferences about the past. This is just about some modern genetic samples, mostly from marmots in this area of uh, called the Tian Shan mountain range on the border between China and Kyrgyzstan. And basically, it's just giving us more information. This is a study that's essentially, again, from the 2019 study, that is just gathering together all kinds of evidence from the documentary record. So we have reason to suspect that this is a pandemic. It's moving widely. But does everything really add up in terms of documentary evidence and the genomic evidence? This is a study from just last year, which is essentially finally giving a map that's saying this is the as close as we can guess right now to the origin, the biological origin of the pandemic in terms of the strains that are directly involved in the pandemic as it is experienced in the Mediterranean. And this is where it's first reported from our documentary evidence. And the big thing to understand about this, and you have a better sense of it because you can see the geography involved, is the time involved is between the Kyrgyzstan sample is probably about the second or comes from the second or third century. The reported narrative we have for the pandemic in the Mediterranean is from the 6th century. So we have to account for at least 4 centuries, maybe 6 centuries, maybe even 8 centuries in this pandemic. So one huge thing that the ADNA is, it's really vastly expanding what we have to conceive of chronologically in terms of how these organisms are moving long distances, moving through human populations, and probably also moving through rodent populations as well. This is another study, which is again trying to figure out this. How do we get from Asia to the Mediterranean? They're saying it's transmitted across the Indian Ocean into the Red Sea and then reaching Egypt. And then bringing in some more kind of military history, social history about how this may have happened. Okay, jumping to the Black Death. And again, I just have to zip through this and end to the debate of what caused it. Yersinia pestis, we don't debate that anymore. Same question as with the Justinianic plague is how do we get a Central Asian pathogen getting all the way over to Western Eurasia? And the problem here is not saying it's not significant. This is my own opinion, is we haven't recognized just how massively more significant it was because we have expanded the chronology. This is from a study just published last week, also, that is embedding the traditional narrative, what I call the quick transit theory, that the Black Death, again, very narrowly defined as starting exactly in 1346, talking about this as the onset of the Second Plague pandemic, that there is no prehistory to this. So it just kind of suddenly comes out of the blue. Diabolus ex machina, as I have called it, still saying it originated in Central Asia in the first half of the 14th century. This is a documentary, a two-part documentary that was released, I think, several weeks ago in Germany. I don't know how widely available it is elsewhere, but basically you can tell everything you need to know by the title, Black Death Patient Zero. The argument is we have found the origin of the Black Death. And the origin actually had already been proposed decades ago with arguments that it began around Issyk-Kul, this very big lake in Kyrgyzstan that we've already heard implicated exactly in 1338, 39, travels to the north of the Caspian Sea, reaches the Black Sea, the episode of Kaffa, of supposedly Mongols throwing plague-ridden bodies over the walls of Kaffa, and then into the Mediterranean basin. So this is an old narrative. The argument in this case is coming from archaeology and genetics. The archaeological work was actually done in the 19th century, and what this group of researchers did was essentially retrieve that archaeological record and study it again. So these are headstones, and this is an amazing site and it's amazing documentation. But also what we need to keep in mind is it's luck of the draw that this even exists in the first place and that it has been found. But what's distinctive about this is a Christian community. They're engraving headstones that they're laying on the graves of people when they die, giving the name, giving the Christian cross, in 400 of about 600 examples, giving the date that they died. And in 10 of those cases, saying the cause of death. So this is grave 30, the one that it's highlighted in red. That's the gravestone. It was in the years 1650, 1338, 39, the year of the hare. And this is the tomb of Kutluk. He died of pestilence, Mautana, with his wife, Mengu Palka. And here's the plan of the cemetery, all of this information. The genetic study now, of course, is new, published in 2020. What's going on here? Again, I don't have time to go through all of this, but basically, the very idea that the Black Death happened, that the whole pandemic started within the space of a decade or so, is in fact a fantasy that's been created because of an intellectual history development that has been going on for 700 years, starting with Ibn al-Wardi in 1349, who himself died of the plague, and building on layer after layer after layer in Islamic historiography, in European historiography, and then it becomes a foundation of scientific historiography, where it's added, this narrative is added into scientific discourse. And by 1951, Robert Pulitzer, who works for the World Health Organization, is basically saying it's coming out of Central Asia. And here, look at this community where we have these dated headstones, which date before the outbreak in Kaffa. Ergo, this is the beginning of the outbreak. However, what Ibn al-Wardi actually said, he said explicitly, yes, it's been going on for 15 years, but it was part of the fiction that he was creating. He was telling a traveler's tale. Amazing study by Omar and Fancy that just came out a few months ago. Anyway, okay, so question is 1338-39 the beginning of this? Is Kara-Jigach anywhere on the map of how this pandemic started? Barbara Tuchman's book, which cannot be recommended in terms of anything it says about the plague, but is still kind of an amazing collection of evidence about what's going on in the 14th century. Her whole argument is there's a lot that's going on in the 14th century. The whole century is calamitous. And what I've been asking, what I've realized I needed to ask was, what if plague is the common denominator for the whole century? What if we've had our chronology wrong? And again, no time to go through all of these, but these are all things that are already happening before the epidemic in Kyrgyzstan, which, to remind you, is 3,000 kilometers away from the Black Sea. So all these other things going on. Other things going on are persecutions that don't start with the Black Death. Actually, there are waves of persecutions in the decades before. And this is just one of the ways in which we're getting new evidence, not simply from genetics, but we're getting a massive waves of new information from archaeology. So the Black Death Cemetery that I showed you at the beginning of the talk, the cemetery in London, was just the beginning, was just the tip of just this mountain of information that is now becoming available from archaeology. This is a site in Austria, and what they found is a lot of mass graves. This is under the Domplatz, under the cathedral square in St. Pölten. And again, they found many mass graves, some of which are comfortably datable to the time of the Black Death, but others are earlier. Those have not yet been tested, or if they've been tested, the results haven't been published. But looking over at Denmark, we can in fact find documentable Yersinia pestis that's 800 years old. So moving back to the 13th century. Okay, again, no time to go through all of these, but again, when we reread the documentary record, we in fact find lots of evidence of major fatality incidents, major mortality. Over on the left there, that's a plaque showing 8,000 people dying in 1 year outside Erfurt. Over on the right is from Czech Republic. Massive amounts of evidence that we called the Great Famine, that we have dismissed for other reasons. We haven't been asking the question, might it be an infectious disease? We already know. Okay, and again, just to say that if we look at the pre-Black Death period, we find persecutions of minority populations. And if we look at the patterns of those persecutions, they're along river basins, often accusations of murder of young boys. We can talk about kind of the sociology of that. Poison is the big thing that gets discussed more than anything else. And this is just another example of ways in which we need to reread the evidence that's already in front of us, coming directly from medical history. Okay, so paths forward. Interdisciplinarity is not a panacea, but maybe One Health is. And this is, again, I'm closing up now, but I just want to lay some questions on the table for us as medical historians. Let's start with the histories we're on the verge of losing. I'm going to be turning 70 years old. I know my generation, which is the AIDS generation, is passing. There's also some ways in which we recognize that the anti-vaccination movement is a movement of amnesia. And what I want to do with this image here is on one of the social media, this was just a few days ago, someone was recounting a story of they were trying to explain to a niece, their young niece, who Paul Newman was. And basically, this older woman was saying Paul Newman was the Brad Pitt of the generations of the 50s and 60s and 70s. And the niece turned to her and said, "Who's Brad Pitt?" And what I want to emphasize is this is Brad Pitt. This is Brad Pitt, the actor. And I was watching this movie just a few weeks ago, and this moment jumped out at me is that Brad Pitt, who was born in 1963, has a smallpox scar on his arm. I have a smallpox scar on my arm, the smallpox vaccinations scar, obviously. But this is the generation that we're moving past. Is interdisciplinarity our hope for dealing with this? And these are really, I think, huge questions that are not articulated enough. What are our ethical obligations? This is a study from Exeter, no time to explain, but basically these are medical historians who are going back and rereading and editing and closely examining in conjunction with the genetic record, the histories of smallpox in the Mediterranean world. This is an image I very often show just to say we have to have all these these disciplines working at the same time. With diseases as complicated as plague, we have to take climate into account. We have to look at people. We have to look at all the ways in which people are acting and reacting. We have to look at the rodents. We have to look at the vectors, and we have to look at the pathogen itself. This whole notion of a One Health movement is essentially saying it's not just humans, but it's also animals. We're all living in a microbial world. Shouldn't we be asking all of these questions in concert and in dialogue? And I already gave you the example of the leprosy study, but what I want to stress again is a historian, Kathleen Walker-Michael, who's a specialist on the history of animals, was deeply involved in that study. And I don't think they could have come anywhere close to getting the results that they did if she had not been involved. The Wellcome Trust itself in London is putting on a genomics in context project where they're deliberately from the ground up saying we have to have genomics, we have to have humanities, we have to have social sciences and bioethics all together. What are our ethical obligations? I won't read this whole thing, but this is from a paragraph I wrote just a couple of months ago. And what I'm basically saying is how much, if we don't take account of the indications that we have to expand our conceptions, how much are we leaving aside? How much are we leaving unexamined? And the point that I make here is focusing exclusively on cottage gosh, which is just, again, we happen to find it. It's an amazing documentation, but it's unique. If we're only looking at the unique outliers and insisting on the centrality of that dating, that means anything that happened before. Kaifeng in 1232, Baghdad in 1258, Europe's Great Famine in 1315 to 18, these persecutions of minorities in 1298, in the 1320s, in 1338. We're leaving all of those off the table. A lot of ethical discussion is coming from genetics, also coming from paleopathology, about how you treat the physical remains. I think we also need to think about the ethical obligations of the narratives that we create. And with that, I want to thank the people who have just kept me alive, kept me sane over the past several years, and to acknowledge that I've had zero funding for any of this. And I can talk about why that's the case, but I thank you all for listening.